Hi, this is a review, or maybe the first time you've seen this, for ionic equations. What these are going to be are double replacement, aqueous solutions involved in a reaction, and a precipitate forms. And so part of this, not new at all. You're just going to write the balanced chemical equation. You have to pay a little bit more attention to the phases that these are in, like if it's aqueous or if it says it's a precipitate, you need to remember that that means it's a solid, and you need to show that in the equation. And then from there, everything else is going to be a little new, but really not that hard. So if you want to pause the video so that you can read the problem that we're going to do together, that would be a good idea. Okay, so it says that we have aqueous solutions of barium nitrate and sodium carbonate, and they're making a precipitate. So that means that this double reaction is actually going to work. It's going to be an actual chemical reaction, and they want me to write the balanced chemical, just assume it's balanced, the balanced chemical equation, something called an ionic equation, and then a net ionic equation. So the first thing I already know how to do, and so I'm going to have my reference sheets in front of me, and I'm going to make sure that I have the charges balanced out. These are all, it's ionic, it says so in the name. These are ions that have to come together so that the electrons can transfer and they balance out to zero. So this is not new. We have aqueous solutions of barium nitrate. Okay, well barium is in group 2 on the periodic chart, so that's a +2 charge. Nitrate, that's a polyatomic ion, it has a -1 charge. So when I put those two together to start out with my reactants, I'm going to have barium, and I need 2 of the nitrates. So I put it in parentheses, and there it is. Now, slightly different than what we've been doing, it says it's aqueous. I'm going to represent that by putting that little AQ as another subscript. The next one is sodium carbonate. Sodium is a +1 because it's in group 1, and carbonate is a polyatomic ion. It's a -2. These are all on your chart. You don't have to have them memorized, you just have to be able to do them. So the next reactant is going to be sodium. I need 2 of those. Carbonate, also aqueous. So these two are going to react together, and they were nice. They told me one of the products, they have to, because if there's no precipitate, there's no reaction. It says barium carbonate is going to be one of the products. So barium still has a +2, carbonate is still a -2. So one of the products is this precipitate, which means it's a solid, so I'm going to put a little S there. Okay, and then there has to be another product because this is a double replacement. So it's when the sodium goes with the nitrate. Remember, positives go with negatives. And it's not balanced, so I need to do that. I think I need to move the camera at this point. High production value here. Okay, so I need to balance it. Remember, polyatomic ions stay together. Nitrate, nitrate, I need a 2 there, and I think that's good. So that's the balanced chemical equation. This is the new part. What happens is, because these are aqueous, I like to think of them like they're all hanging out in a hot tub. The ions separate in the water solution. That's why they conduct electricity, because they separate and they're allowed to pass charge through them. So the barium and the nitrates, they're hanging out together, and the nitrate and the sodium and the carbonate, they're hanging out but separated as ions. But then they react, and this solid gets out of the hot tub and settles to the bottom. So this is a solid, this still aqueous, still aqueous. So what we're going to do in the ionic equation is we're going to separate all of these using the coefficients and the parentheses to show how many ions are hanging out in the hot tub. So you take the first one. Barium is a +2. And there's just one of them. And it's aqueous, and you can put aqueous down here. And then there are 2 nitrates because of that parentheses. Each one is a negative charge. Remember, the point of this is to show the ions. It's an ionic equation. So there's 1 barium, it has a +2 charge, make sure you put the charge, and it's aqueous. There are 2 nitrates, each one has a -1 charge, also aqueous. And you just continue to do this for the reactants. So I have 2 sodium, positive, aqueous, and 1 carbonate, -2 charge, also aqueous. So you separate the reactants into their ions, and these are what are hanging out in this water solution. The water is just a resource for them, I guess. I call it the hot tub. And now what's going to happen is the reaction, the barium goes with the carbonate, and it makes a solid. So that's not split apart. They're not split apart in the hot tub anymore. They're gonna settle because of gravity to the bottom. So they stay together. The precipitate stays together. Put your little solid down there. As soon as you see that's a solid, they're not in the hot tub separately anymore. They came together in the reaction and dropped down to the bottom. It's a precipitate. But this sodium nitrate did separate. Aqueous. So you separate it just like you did the other side. Just remember that the coefficient stays with it. See this 2 here? So there's 2 sodium, aqueous. There's 2 nitrate, also aqueous. I should probably make my 2's all the same, but you're probably used to it by now. So that's called the Ionic equation. You just separate everything. Now this is the weird part. To get from ionic to the net ionic, the word net means like overall. Like if you have a job, let's say you work at Chick-fil-A and you make a certain amount an hour and there's your pay. Well, that's not what you get. What you get on your paycheck is your net pay after everybody takes out their part. That's how this is. This is the net ionic. So what happens is, if you've got something to the left of the arrow that is also present to the right of the arrow, it can cancel out. They're called spectator ions. They didn't do anything. They just hung out in the hot tub. So I've got barium on this side. There's no barium over here. It's not a spectator ion. I've got 2 nitrates. Oh, there's 2 nitrates. Nitrates didn't do anything. Spectators, they're gone. Cancel them out. They're just hanging out in the hot tub. We've got 2 sodiums. Oh, I got 2 sodiums here too. They cancel out. Spectator ions cancel out. They're just hanging out in the hot tub. Carbonate, nope, carbonate, still there. Once I've canceled out the spectator ions are the same as a reactant as they are a product. They did not take part in the actual reaction. So what I do in the net ionic is I show what took part in the actual reaction. It's what I have left over, and I write it exactly like I did in the ionic. So I have barium, and it was aqueous, and I added to that a carbonate, and it was aqueous, and then I ended up with a precipitate. And if you've done this correctly, it's balanced, and that's how you know you did it correctly. It's balanced 2 different ways. There's something called a conservation of charge. You can't lose electrons, you can't gain protons. So is the charge conserved? Does it stay the same from side to side? And are the same elements present in the same number? So I have 1 barium ion, 1 barium, and I have 1 barium, and I have 1 carbonate, if you want to think of it like that, or 1 carbon, 3 oxygens, 1 carbon, 3 oxygens. So element-wise, conservation of mass or matter-wise, it's fine. Charge has to do the same. +2, -2, 0. There's no charge over here. And +2, -2, math class, it adds up to 0. So that's how you do the net ionic equations.